Analysis of the evidence available. The undersea pipeline stretches 1,200 kilometres, that is 745 miles, under the Baltic Sea from the Russian coast near St. Petersburg to northeastern Germany on 29th of September 2022. The two pipelines of the Nord Stream 2 will have a capacity of 27.5 billion cubic meters a year. Each will comprise of 12 metre long individual pipe joints. Each pipeline is made of 100,000 coated steel pipes with 24 tons in concrete weight. The internal diameter of the pipeline is 1.153 millimetres, that's 45 inches, and the wall thickness is 41 millimetres, that's 1.6 inches. This information was published on the 1st of March 2022. I'm reading this from information which was supplied and published. That explains why I'm not doing it very well. The main defence that the pipeline has against corrosion is the anti-corrosion coating. The bracelet anodes are designed to protect the pipeline where any voids, pits or other coating failures may occur during installation or during the operational life of the pipeline. This was published on the 1st of May 2011. Sacrificial bracelet anodes typically are either zinc alloy or aluminium alloy, depending on the design requirements, environmental variables and water salinity. Both alloy types were used in the fabrication of the anodes of Nord Stream 1, published on May 2011. Each line of the pipeline was made of about 100,000 concrete weight-coated steel pipes, each weighing 24 tons, which is 53,000 pounds, welded together and laid on the seabed. To facilitate pigging, the pipelines have a constant internal diameter of 1.153 millimetres, which is 45.4 inches, according to the Nord Stream publications. Gas travels the full 1,224 kilometres distance to Germany's Baltic coast, thanks to input pressure of about 220 bar generated by Gazprom's state-of-the-art Portovaya compressor station. The following drawings show the forces that come into play during this operation. The pipeline is subjected to atmospheric pressure plus the weight of the water plus the weight of the backfill caused by gravitational attraction of the Earth's core. So we have the atmospheric pressure, the weight of the sea, and the weight of the backfill, and the pressure of the gas in the pipeline is balanced against these pressures. Pressure of the gas inside the pipeline, which is exerting a force against the tensile strength of the 1.5-inch steel wall thickness, and additional reinforced concrete weight coating that stops the pipeline from floating. This adds to the compressive strength of the pipeline. That is the compressive strength. The next picture. This shows the shock waves caused by an explosion. If there was an explosion above the pipeline, the shock waves would be dampened by the backfill and the concrete weight coating. If this was above a bracelet anode, the shock would be directly to the pipeline metal. If the anode had been depleted by accelerated corrosion, the shock would be directly to the pipeline metal and would also, if the pipe anode had been depleted by accelerated corrosion and the pipe metal itself was also dissolved to 50% or more, a shock wave from above might cause failure. The science behind this can be compared to the science behind the use of depth charges against a submarine, which has an irregular shape, and the joints in the metal structure are strained by violent changes in the forces playing on them, with only breakable air pressure internally. However, we know that the internal pressure was significant to burst the pipe, was sufficient to burst the pipe violently, with sufficient explosive force to overcome all the gravitational pressures and the remaining tensile strength in the pipeline metal. This is shown by the results which were photographed of the gas escaping from the pipeline and reaching the sea surface, where only atmospheric pressure was opposing to the pressure of the gas coming from the sea. There is visual evidence to confirm that the pressure of the gas overcame all external pressures, plus enough force to force bubbles of the gas to rise to the surface and disturb the waters to the extent which is seen. This is another view of the gas escaping, with the tide bringing the bubbles in this direction. The following is from a report by an expert, and while we do not even know for sure how bad the situation is, the damage is expected to be significant. The September 26th blast, believed to have caused the pipeline ruptures, registered 2.2 on the Richter scale, according to the Swedish National Seismic Network. Swedish and Danish investigators, who have taken the lead on probing the links because they happened nearest to their countries, have said that they were caused by blasts equivalent to several hundred kilos of explosives. And here the pictures show the route of the Nord Sea pipeline through to Germany.